Welcome to Theory of Computation class. In today's class, I am going to explain extended transition function for epsilon NFA and the problem which comes under the conversion of epsilon NFA to NFA. So here you aware that epsilon NFA is also a mathematical model which comes under a non-deterministic finite automata in which epsilon will also be considered as an input symbol including the alphabet symbol. So for that concept, how can you calculate the extended transition means this is the formula. That means the extended transition function notation is called as tilde cap. So tilde cap of q comma w. W means a set of string in which we can able to calculate epsilon closure value. Okay, so let w is equal to xa means that means w is a string which contains two symbols in it, x and a. So if you want to calculate the extended transition function of tilde cap of q comma w, the formula is epsilon closure of tilde cap of q comma epsilon comma a, which means that we are separating w with the two symbol. So first you should calculate the extended transition for x symbol, then you calculate the value with a symbol. Then how can you calculate an extended transition for a single input string? That means tilde cap of q comma x, which means that tilde cap of q comma epsilon comma x. So if only one symbol is there, x is an alphabet symbol, then if you want to calculate tilde cap of q comma x, the formula is tilde cap of q comma epsilon comma that symbol. This is nothing but your epsilon closure of q. So we already know about the calculation of epsilon closure of q. So if you want to calculate epsilon closure of q state, this state should be included. Then from this state you should find out what are the outpath of epsilon to outgoing states. So these values are available. So this is the calculation of epsilon closure of q, which is shortly note it out tilde dash of q comma epsilon. So the resultant answers are available. It is a set of states. For those set of states you should calculate x transition value. So this is the extended transition formula. Let us discuss an example. So here this is an epsilon NFA diagram. So this is an epsilon NFA diagram in which q naught contains 0, 1 and outflow of available. We want to check a w value, that is 1, 1. So this is for sample example. First you should calculate epsilon closure value for the given states. So totally 3 states are there. So you want to first calculate the epsilon closure values for these 3 states. So you first include the states. So Q0, Q1, Q2. From Q0 epsilon flow goes to Q1 state. From Q1 there is no output flow of epsilon, so the state is closed. If you check the epsilon closure of Q1, from Q1 there is no states, so the answer is only Q1. From the epsilon closure of Q2, there is no outpath of epsilon from Q2 state, so only Q2 is available. So this is the epsilon closure value. Then extended transition tilde dash. The starting state is Q0 and the checking string is 1, 1. So what is the formula? You can able to write it as epsilon closure of tilde cap of q naught comma 1. Then the separate one will be available here. Okay, then so you write epsilon closure of tilde of, this will be rewritten as tilde of tilde dash of q naught epsilon comma 1. Okay, so this is already calculated, which is nothing but epsilon closure of q naught. So you write the answer. So what is the answer for this one? This is q naught q1. Okay, then First you should find out tilde flow of Q0 Q1 with 1 from the given epsilon NFA diagram. So you just check it out. You can separately write it as tilde of Q01 union tilde of Q11. First you should calculate the value. So first you should calculate value. So you just check here from Q01, Q0 state is there. From Q11, Q1 is there, Q2 is there. So you write the answer. So tilde of the answer for this one is Q0, Q1, Q2 and again 1. Then epsilon closure of, you can separately write it as tilde of Q01 union tilde of Q11 union tilde of Q21. So you just check it out from the given diagram. Q01 is Q0. Q11 is Q1, Q2. Q21 there is no values there. So you should find out epsilon closure of these three states. So this will be written as epsilon closure of Q0 union epsilon closure of Q1 union epsilon closure of Q2. So the answer is for epsilon closure of Q0, the answer is Q0, Q1. Epsilon closure of Q1 is Q1 that is already available in a set. Epsilon closure of Q2 is Q2. So this is the answer for the outflow. So what is the meaning? Means from the starting state Q0, if you give 1 input, the first one input goes to Q0. Then epsilon means empty flow. So it goes to Q1 state. From Q1, second one goes to Q2 state. This is 1 answer. Okay. So from the given set, the final state Q2 is appeared. So this is a correct input string. So this is the answer for extended transition notation. Is it clear? Okay. Thank you. So this will be written here. Then what is the difference between tilde cap? Tilde is only checking the input symbol, only one input symbol, but tilde dash, that is extended transition function, that is used to check the validity of string. So we are checking only the validity of string in the previous example. Then the next problem is conversion of epsilon NFA to NFA. So the theorem says that if L is a language which is accepted by NFA with epsilon transition. So the meaning of this one is it's nothing but epsilon NFA. So if a language L is available or it is accepted by epsilon NFA, then the same language L should be accepted by NFA without epsilon. So this is the theorem. And these are all the steps that should be followed for proving the theorem. So the first condition is, so how can we convert epsilon NFA to NFA? Means the same set of states available in epsilon NFA is also available in NFA without epsilon transition. Okay, so step 1, what are all the states available in epsilon NFA? You should calculate epsilon transition function for all the states in epsilon NFA. This is step 1. Step 2, you should calculate the extended transition function tilde dash. So I already discussed the extended transition function. That means tilde dash of q comma x is equal to epsilon closure of tilde cap of q comma epsilon comma w, where x is a string. Here we are taking x is an input symbol in sigma. So we should repeat these steps for finding the transition function for all the input symbols and all the states. For example, if the epsilon NFA contains 3 states, so set of states are 3 and set of symbols are 2, means tilde transition function, how many transition functions should be calculated? Means 3 into 2, 6 transition function we should calculate. For example, if I am taking Q or Q0, Q1, Q2 and the sigma may be AB, means we should calculate tilde dash of Q0A, tilde dash of Q0B, tilde dash of Q1A, tilde dash of Q1B, then tilde dash of Q2A, tilde dash of Q2B. So you should calculate these 6 functions. That is the meaning of this one. Then after calculating all the resultant transition functions, we should draw NFA. That NFA does not contain epsilon in it. Then if you draw a diagram, we should find out the final state. So how can you find out the final state means we already know the final state of epsilon NFA from the given diagram. If any diagram is given, we can able to find out the final state because that particular final state contains double circle in it. So which state contains a double circle, you should calculate the epsilon closure of that final state. So it contains a set of, it will give the set of states. Those set of states will be considered as final state for the resultant NFA states. So this is the procedure. Then in the next class, I will explain the problem with a simple example. Thank you.